Hello and welcome to this video user guide for the MCS online software for Heat Load Calculator. The video is intended to enhance your experience with the software and help answer any queries you may have when entering the data into the calculator. The video has been broken up into sections should you wish to skip to a specific part. You will start by logging in. Click the Login Now button. Once you've selected the relevant account, you'll be able to start your new calculation. Click plus New Property. In the Property Information section, the first thing you need to do is enter a unique reference for the calculation. This can be an address, say like 1 the High Street, or maybe if you are doing a calculation that is a hypothetical scenario, say for instance once some insulation has been added to the roof, you could call it 1 High Street 400mm of loft insulation. This will ensure you can identify different calculations. You must always enter something into the reference field. Next, you must enter a postcode for the dwelling you are assessing. Again, it is essential this is correct as the software uses the postcode field to auto-complete the location data and design condition fields in the software, which sets the basis for the rest of the calculation. However, you can override these fields. To change the country, you can click the drop down. The altitude, as we mentioned, is derived from the postcode and shows the altitude of the building at ground level. This is especially important if the height is above 100 metres due to increased infiltration that will be included in the final calculation. Moving on to the Design Conditions section, once again this will be pre-populated based on the postcode you have entered. However, due to the flexibility of the MCS Heat Load Calculator, the values can be overridden if you wish using the Override button as shown here. Remember that if you do override certain fields, such as design external air temperature, mean annual external air temperature and heating degree days, your calculation may not be MIS 3005D compliant. As a reminder, the design external air temperature is used to determine the temperature difference between the room and external air when calculating the peak heat load for the building fabric. And the default temperature is obtained from the closest weather station to the property as the crow flies, or in other words, straight line distance. The mean external air temperature is based on an entire year and is used as the assumed ground temperature when calculating the heat loss of solid ground floors and basement walls if you have them. Both of these temperatures are shown in Celsius and can be overridden if you wish, as mentioned earlier. Heating degree days is another auto-filled field derived from Met Office historical weather records using a base temperature of 15.5 Celsius. Following this, the property details will need to be entered next. The dwelling type, attachment and age bands are all taken from the RDSAP methodology. So the dwelling type and attachment type require data to determine the number of heat loss surfaces of the dwelling. The age band that uses building regulation standards from the selected years to determine the U values of the fabric of the building or heat loss surfaces, along with the air changes per hour and design room temperatures. All of these can be selected using the drop-down menus. So in this section we're selecting house, semi-detached, looking at the RD SAP age bands, band A before 1900. Moving on to the number of occupants. This is important as a calculator needs to determine if the number of occupants exceeds what is expected in a property of that size, and if any additional ventilation is required. To do this, you can click on the toggle switch on the left and right, or just type in the number of occupants. Next, the dimension specification needs to be selected. This is essentially how you have measured the property. It is most likely here that net internal will be selected if you have visited the dwelling, as it involves measuring internally from floor to ceiling from the internal faces of the walls on a room by room basis. However, should you wish to select gross internal, you will need to measure from the centre line of the internal walls, and heights are taken from the floor structural level to the same level as the floor above and incorporates the intermediate floor height. Floors and ceiling measurements are taken from the interior face of the boundary external walls to the centre line boundary internal walls. And if you were to measure from plans, you may wish to use gross external, as wall widths are taken from the exterior face of the external wall to the centre line of the internal walls. The height of the wall is the total story for each floor. Floor and ceiling measurements are taken in the same way. Building air tightness can also be entered in three different ways. The standard method assumes an infiltration rate based on the number of bedrooms and occupants in the dwelling using SIBSE tables. If an air test has been performed on the dwelling and you have the building envelope area and volume that were recorded during the test, the data can be entered into the measured air permeability section. Finally, if you have a whole house design air change rate, enter this into the air changes per hour in the design air change rate box. Also note, individual rooms air change rates can be altered and added in the heated room section. The final section of the property information requires you to answer if you have a measured HTC or heat transfer coefficient test, and if this has been performed on the dwelling. If so, the details of the test can be entered into the box below. Moving on to the ventilation section, the first thing to select is the number of distinct ventilation zones in the dwelling. Rooms that share the same ventilation system constitutes a zone. For each ventilation zone, you will identify the number of stories, number of external facades, and how many of these facades are sheltered from the wind, along with the ventilation type for that zone. The number of stories is pretty self-explanatory and helps the calculator calculate the heat loss through infiltration for that specific zone. The number of shelter sides is taken from the SAP methodology and the facades of the building that are protected from the wind by things such as trees, buildings, tree height hedges that are adjacent to the building. Also remember that an attached dwelling will obviously have a party wall and will always be considered sheltered on that attached side. If you look at SAP, it will tell you a side is considered sheltered if it is effectively obstructed from the wind with all of the following applying. The obstacle providing the shelter is at least as high as the ceiling of the uppermost story of the dwelling. The distance between the obstacle and the dwelling is less than 5 times the height of the obstacle and the width of the obstacle, or the combined width of several obstacles. is such that it subtends to an angle of at least 60 degrees within the central 90 degrees when viewed from the middle of the wall of the dwelling that faces the obstacle. Finally, in each zone, you must select the ventilation type for that zone. Natural ventilation will be selected if you do not have a full mechanical system in place. So if you have individual ventilation devices, such as extractor fans on pull cords or humidity sensors in individual rooms like a bathroom or kitchen, for example, or air bricks, you'd select natural ventilation. If you have a mechanical system installed in that zone, you can select either mechanical extract ventilation, MEV, mechanical ventilation, MV, mechanical ventilation with heat recovery, so that is MVHR, or positive input ventilation, PIV. If you do select mechanical ventilation with heat recovery, you are required to enter the percentage of heat recovery in the box. Usually this is something that will be supplied by the manufacturer. The data for the supply and extract flow rates are taken from SAP and converted into an airflow volume based on the total internal air volume of that ventilation zone. Once you have completed the ventilation section, it's time to enter your heated rooms within each ventilation zone. Upon selecting the Add Room button, you'll first need to select the ventilation zone that the room is applicable to. If you only have one ventilation zone, you will only be able to select Zone 1. You will then need to select the room type, which is derived from CIBSE tables and SAP. This will determine the design temperature and air change rate for that room. However, if you are designing to a different minimum design change rate or design room temperature, these values can be overridden using the override button. In the case of design room temperature, the temperature can only be increased and must not exceed 30 degrees Celsius. Please note that if you do override the preset values, your design may not be MIS compliant. The calculator will automatically assign a room name. However, you can also enter your own room name into the room name box, which is useful if you have more than one room of the same type. For example, if the property had 3 bedrooms, you might want to call them Bedroom 1, Bedroom 2 and Bedroom 3, or maybe Master Bedroom, Rear Bedroom and Roof Bedroom. The max ceiling height should also be entered using 2 decimal places for the best accuracy. In the cases of sloped or vaulted ceiling, this is the highest point of that room. If for whatever reason you are unable to measure the ceiling height, a typical value of 2.4 can be used. You can also enter data for advanced options such as intermittent heating and heat gains. However, this is only recommended for experienced users who have access to this very specific data. The process is repeated until you have entered all of the heated rooms in the dwelling. If you wish to edit or delete any of your rooms, simply select Edit to open up the room details or Delete to remove it. Now let's start adding the building elements. I like to start with walls, so let's start by adding a wall type. The selections available to you will depend on the attachment type for the property. For example, if you have a detached dwelling, you'll get the option of external wall, internal wall and no new value. Whereas if you have a dwelling that is attached, for example semi-detached, mid-terrace, end-terraced, enclosed mid-terraced or enclosed end-terraced, you'll get the option of party wall as well. If you select external wall, the calculator will prompt you to enter the age band for that wall and its construction type. Once you've selected the relevant age band and wall construction, you are prompted to complete the additional insulation drop-down. Should the wall be in its original state and it's an original construction, select None. Should additional insulation have been added since construction, select the appropriate from the drop-down list. It is important to remember that the calculator uses assumed U values for the walls based on their age band and construction type, so only select additional insulation if insulation has been added since construction. For example, a solid brick constructed wall constructed during band A pre-1900 with 100 mm of external insulation will have had its insulation added after construction. The data for building elements is derived from RDSAP, so for example, should you select timber frame construction, you will only be able to select internal wall insulation as you're unable to enter a depth for that insulation. Furthermore, if you have a solid stone wall with internal or external insulation, select solid brick or stone for your wall type rather than solid granite whinstone or solid sandstone limestone. This will enable you to add additional insulation. When you enter internal wall, the calculator will ask for the construction type of that wall. The four options available to you are aerated block, breeze block, solid brick and stud partition. Select the most appropriate wall type from the list. If you're unsure on the wall type, as it is often difficult to tell an internal wall, I'd recommend selecting the worst case scenario. Obviously, if the wall sounds hollow when tapped, timber stud should be selected, but if it sounds solid, it's likely to be solid brick unless the wall is constructed from the 1980s on. Solid brick are the worst performing walls in terms of U values for masonry type walls, so if it sounds solid when tapped and you're unsure, select solid brick. If the dwelling is attached, a party wall option will appear. The options available are unknown, cavity filled, cavity unfilled, solid brick and system built and timber frame. Finally, in the walls section, if you have a wall where you have a measured or design U value, this can be entered by selecting the known U value category. You can also enter a thermal bridging if you wish, and if the wall is a basement wall, instruct the software if it accounts for good ground contact. Moving on to floors. Here you'll enter all of the floor types within the dwelling so that they can be added to the appropriate rooms later on in the calculation. The options available will depend on the dwelling type and are ground floor known insulation, exposed floor, internal floor, party floor and known U value. If you have a floor that sits on the ground and you do not know what insulation is present and there is no insulation at all, select ground floor. From here, you can give the floor a memorable name such as ground floor no insulation or solid for example, or stick with the suggested name in the calculator. From here, select the floor construction of that ground floor, which will either be solid concrete if it sits on the ground, or if it's off the ground, it will be suspended timber, chipboard, beam and block. The age band of the floor is based on the RDSAP age bands. And finally, the wall construction that is connected to the floor will need to be selected. If you know what insulation is present in the ground floor, you need to select ground floor known insulation from the category section. As previously mentioned, select the appropriate floor construction type. This time, however, you will be required to enter the insulation thickness in millimetres and wall thickness in millimetres. So remember, if you are visiting site to produce your calculation, that you make a note of these measurements. Both measurements cannot be more than 999 millimetres, and should the property have a floor that separates a dwelling from an unheated space, so say for example a garage, exposed floor should be selected. Once again, the age band of this floor must be selected. As with all floor types, if you're unsure, go with the age band of that building part. Following that, the thickness of the floor insulation must be selected. As built and unknown are available as they are directly imported from RDSAP. Where it would be essential the correct option is selected If you cannot see insulation in RDSAP, in Heat Loss Calculator either can be selected, as it will default to the level of insulation installed as per the building regulations of the age band selected for that floor. If insulation is present, you can either select 50, 100 or 150 millimeters. Should you have an internal floor, the process works much in the same way as previously described. Select internal floor from the category list, give the floor a name, or of course you can accept the default given, and then finally you will need to select one of the two drop-down options from the menu for internal floor construction. If you do not know what insulation there is, or if there is less than 100 millimeters, select intermediate unknown less than 100 millimeters of insulation. Or if there is more than 100 millimeters or 100 millimeters of insulation, select intermediate equal to or more than 100 millimeters of insulation. And then moving on, if you have a flat or apartment or a masonette, you will have the option to enter a party floor from the category list. This is a floor that separates the dwelling from a neighbouring property, i.e. if you have a flat that is above another separate flat. The floor of that flat you are assessing would be entered as a party floor. Once again, choose a name for the floor and then you will be prompted to enter the party floor construction type, and if it has any insulation present. These options available to you are timber uninsulated, timber 100 millimeters of insulation, timber 150 millimeters of insulation, concrete uninsulated and concrete 100 millimeters of insulation. As with the walls, if you have a measured or designed U-value, you can select a U-value from the category list. Enter the U-value, and if it accounts for ground contact with a solid floor, if you know the thermal bridging factor, this can also be entered here too. Now we move on to ceilings. Here you'll enter all of the ceiling types in the dwelling so they can be entered into the relevant rooms later on in the calculation. You will have 4 options available to you depending on the dwelling type selected: external roof, internal ceiling, party ceiling, and of course known U-value. If selecting external roof, you will be invited to give the roof a name, or you can use a suggested name. As I mentioned earlier, giving a building element its own name is really useful when it comes to building up your rooms later on. I think this is especially important for external roofs, as, for example, you may have one roof that is pitched with 100 millimeters of insulation and another which is a flat roof with 100 millimeters of insulation. Giving each element a defined name helps you avoid mistakes later on. As per the wall and floor elements, you will first have to select an age band for the external roof, and that's based on the RD-SAP age bands. This will help determine the U values for that element. Then you must select the roof types. 3 options are available. Here it's pitched, slate tiles, flat roof or thatched roof. The insulation depth must also be entered with a maximum depth allowed of 999 millimeters. If you do not know the depth of the insulation or are unable to access the lot space during the physical inspection, the unknown box can be selected. Moving on to the external ceiling, which is of course a ceiling that separates different stories within the same dwelling. As usual, you'll be invited to give that ceiling a name, or you can go with the suggested name. Then the only other selection you will need to make here is the internal ceiling construction type. You will get this option of unknown, less than 100 millimeters of insulation, or intermediate equal to or greater than 100 millimeters of insulation. Then, as previously discussed, if you have a known U-value or a designed U-value, measured U-value, you can enter it using the U-value category. You can also enter the optional thermal bridging factor. Moving on to door types within the dwelling. Here you'll enter all of the internal and external door types for the dwelling being assessed. The options this time are external door, internal door and no new value. Ensure you add all of your door types here so they can be used to build up your rooms later on. Pretty self-explanatory, but if you have a door that separates the dwelling from the outside, external door needs to be selected. As with all the other elements, you can give the door a unique name if you wish. You must then select the age band of that door. Once again, age bands for RDSAP are used here. You must then select if the door opens directly to the outside, or in the case of a flat apartment, if it opens to a heated or unheated corridor. Once again, the selection for internal door is pretty self-explanatory, and then this time there are 5 options to choose from. Solid wood 25% single glazed, solid wood 50% single glazed, solid wood 25% double glazed and solid wood 50% double glazed. And then moving on to no new value, which can be entered for your door along with the optional thermal bridging factor. So window types, the final building element to enter is the window type. Here you will enter all of the external and internal window types within the dwelling so you can build up your rooms later on. The categories are the same as doors: external window, internal window and known U value. Starting with external windows, as usual, you can enter your own window name if you wish, or go with the software's suggestion. You are then required to enter what glazing type is present in that window, whether it's single glazed, double glazed, triple glazed or secondary glazing. Next, the frame type will need to be selected. This is basically the material the frame is made from. The options here are UPVC, metal or wooden. If you select double glazed as a frame type and UPVC, some further details will be required from you. Once again, these options are taken from RDSAP. You will need to confirm if the year the window was installed was pre or post 2000 and what the size of the glazing gap is. Options here are 6mm, 12mm or 16mm or more. If you are unable to tell what the glazing gap is, then it is recommended that 6mm is chosen if the gap looks narrow and 16mm if the gap looks wide. If the window is a roof window or on a flat or pitched roof, click the box. Don't forget, if you have 2 windows of exactly the same glazing type, frame type, year installed and glazing gap, if one is on the roof and the other is in a wall, you will need to create 2 window types. This is where your window name field really comes into play to enable you to distinguish between the two, which is essential as it will have an effect on the fabric heat loss. If you have an internal window, you need to select it from the category list and give it a name, or stick with the suggestion. From here, it's simply a case of identifying the window as single, double or triple glazed. As you've become accustomed to, the U value for the window can also be entered, along with the optional thermal bridging factor, by selecting U value from the window category. Now that you've built up all your building elements, you are ready to start building up your rooms. Remember that if you forget an element or a heated room or anything else for that matter, you can always go back and add it. Or if you need to make a change to an existing heated room or building element, that can be done too. In this example, we will show you how to enter the lounge into the calculator. The room is built up using walls, floors and ceilings. You can also add any ventilation devices that are in that room and the internal air volume if you have opted to use gross external dimensions, or if you wish to override the internal air volume already calculated if you have used net internal or gross internal dimensions. As you can see from the floor plan, the majority of the lounge sits below bedroom 1 with a small bay window to the front, which is obviously an exterior wall. The bay has a flat roof and there is a party wall to the right hand side. An internal door leads from the lounge into the hall, and an internal window separates the lounge from the kitchen. I like to start by entering the walls. To do this, click on the Add Wall button at the top right. I also like to split off the different wall types and enter them separately. However, you can do whichever suits you best. So let's start with the exterior wall for the bay window. So select the adjacent spaces exterior from the list, and from my inspection I've determined that the exterior wall is solid. I have entered this in previously in the building elements section, so the drop down menu can select solid brick external. I know from the floor plan that I have produced that the width of the exterior wall is 1.83 plus 0.52 plus 0.52, making a total of 2.87, so I will type this measurement into the box named width. Having measured the height of the wall during my inspection, I found that it was 2.50 metres high, so I entered that into the height box. The software will automatically fill in the area for me, so 2.87 times 250 is an area of 7.175 metres squared. If you wish, you can just type the area of the wall without entering the dimensions, or if you've already entered the dimensions, you can click the override button to type your own area in. I now need to add the window into the external wall, in this case the bay. To do this, click on the window icon displayed on the screen and enter the details. Based on my previous entries in the building elements section and the fact that the wall is exterior, the calculator is able to narrow down the options to exterior window to help me with my input. Select this from the drop down and proceed to enter the total area in for the dimensions. In this case, based on my on-site measurements, I know the width of the window is 2.87 and the height is 1.56. Now to enter the remaining portion of the exterior wall, so once again select the Add Wall with the adjacent space being exterior. The wall type is once again solid brick as per the floor plan. 1.60 plus 0.97 is 2.57, so I enter this into the width box. I also know that the height of the wall is 2.63 from when I visited the property, so 2.63 goes in there. The total area is displayed, but as always can be overridden if you wish. Moving on to the internal wall adjacencies, so let's start with the kitchen, as this is a heated room, and select the appropriate option from the adjacent space list. As we have already stated, the adjacent room is the kitchen based on the floor plan, so select that from the drop down. I have previously determined that all the internal walls in the dwelling are solid, so I have entered a solid brick internal wall into the building elements section. So select this from the drop down list. Looking at the floor plan, the width is 4.40 and I know the height of the wall is 2.63. As with external walls, the area can be overridden or entered in rather than the room dimensions. Next, I need to enter the internal window that separates the lounge from the kitchen. Once again, select the plus window icon and the appropriate wall, and in this case the kitchen, and enter the dimensions or the area. 1.83 for the width, and it's 1.70 for the height. We follow the same process for the hall wall adjacency. Select the heated room with the adjacent room being the hall. And for the dimensions this time, we're going to go with 4.58 for the width and 2.63 for the height. This time we have an internal door that separates the lounge and the hall. So we need to click on the plus door option in the adjacent space hall and select the relevant door type, which in this case is internal. The dimensions are already filled in. The software does have a predefined internal door size which you can use. The final wall to enter is the party wall. Once again, click the Add Wall to select the adjacent space as neighbouring building. I have already entered the wall type into the Building Elements section, so in this case I'll select Party Wall from the drop-down list and enter the dimensions, which are 4.58 for the width and 2.63 for the height. Now I have entered all of the walls for the lounge, it's time to enter the floors, and again I like to split these off into easy to define areas, but you could enter all of the floor as one area if you wish. Click on the Add Floor, and as this is the ground floor and I know the floor is suspended, I select the adjacent space to be ground suspended floor. I have previously entered the suspended floor into the Building Elements section, so I will select this from the drop down. I am going to enter the main area, not including the bay, so the floor plan shows that to be 4.58 by 4.40, so in the width type 4.58, in the length 4.40. Of course you can just type the total area into the area box if you wish. It's important to remember that with the ground floor you must also enter the length of the exposed perimeter. That's so the software can work out the heat loss at that junction. In this case, I am entering the main area of the floor, not including the bay. So my exposed perimeter is 1.6 plus 0.97, a total of 2.57. Now, for the floor area of the bay window, again it's the same process. Click Add Floor with the adjacent space being suspended floor. The width, that's 1.83, and of course the length is 0.52. And now we're going to enter in the exposed perimeter, which in this case is 2.87. Now moving on to the ceilings. So this is entered much in the same way as the floors. The first thing you need to do is click the Add Ceiling button. This time we will start with the adjacent space above as being bedroom 1, as shown on the floor plan. As this is a heated room, this should be selected from the adjacent space menu. We have already stated the adjacent space is bedroom 1, so select that from the drop down list and then enter the ceiling type as an internal ceiling. Now, it is simply a case of entering the area of that ceiling either by typing total area in the box or entering the width and the length. In this case, I can see the width is 4.58 and the length is 4.40. Now, we move on to the bay window area, which has an exterior flat ceiling. So once again, click the Add Ceiling, and this time the correct adjacent space is exterior, no loft/roof void. As you may have guessed, I have already entered the flat roof into the Building Elements section, so select this from the drop-down menu. As we know from when we did the floors, the width of this is 1.83 and the length is 0.52. The last part of the room is the ventilation devices. Now, this does not include whole house ventilation systems like mechanical ventilation, for instance. It's just individual items. So the available options are shown here as chimney or flue closed fire, chimney or flue solid burner, chimney or flue other heater, chimney open, chimney blocked, flueless gas fire, intermittent extractor fan, other open flue vertical duct, and passive vent. You are also able to enter the design flow rate if you wish, or unknown if you do not know. In this case, there is not a ventilation device in this room. Once you have completed the room, click Save and Continue to move on to the next one. As you can see, I have pre-entered all of the rest of the rooms of the dwelling into the calculator. You will need to add them yourself one by one. Once you've entered each room and click Save and Continue, you will get your result calculation. Your result calculation will show the peak heat load by floor area, and annual energy estimate, amongst a lot of other data. It will also split the property down on a room by room basis, as shown here in space heating load by room. It will show the fabric heat loss and also the heat loss by ventilation zone. This property only has one ventilation zone. You can also export your file as a JSON file so it can be imported later on back into the calculator. You can also print your results and save them for future reference.